This is a video about derivation of tangent lines to curves. It is particularly interesting because part B may be a little bit difficult for some people, but hopefully after watching this video you can tackle similar problems. Right, we are given a curve with a cubic equation and we are asked to find the equation of a tangent at a point P, and they have given us the coordinates of point P, which is -1. Now, to find the equation of a straight line, we need to know its gradient, and also we need to know, at least have one point at which the line passes through. Now we have the x coordinate of the point P. We first need to find the y coordinate of P. So if I substitute -1 in the expression for my y, I should get the y coordinate of P. So y at P, y sub P would be equal to 1/3 of -1 cubed minus -1 squared minus -1 and +1. So this would equate to 1/3 minus 1/3, because -1 cubed is -1 times 1/3 is -1/3. -1 squared becomes +1, and we have a negative outside, so this becomes -1, and -1 becomes +1, and then we have a +1 at the end. The two ones cancel here. This becomes 1 minus 1/3, which becomes 2/3. So we'll have the point P has coordinates -1 and 2/3. Right, so we have the coordinates of the point P, and now we need to find the gradient. The gradient is given by differentiating the equation for our graph. So we have dy dx is equal to derivative of 1/3 of x cubed would be x squared, because it's 3 times 1/3 and times x squared, then minus 2x, and then we have a -1. Now at P, dy dx will be, we substitute the coordinates of x in the expression for dy dx, so we get -1 squared, which will be 1, and then -1 times -2, which will be +2, and then -1, so it becomes 3 minus 1, which is 2. So our gradient is 2. And the way we would write the equation of a line, just as a reminder, if I have a line with gradient m going through points P with coordinates x of P and y of P, the equation of such a line would be y minus y of P is equal to the gradient times x minus x of P. Okay, so we have a line, we know our gradient is 2, and it's going through the points P at -1 with coordinates -1 and 2/3. So the equation of a excuse me, our tangent line would be y minus 2/3. That is equal to 2 is our gradient times x minus 1, which will be x plus 1. So this will be y is equal to 2x plus 2, and then I'll move the minus 2/3 to the right hand side, becomes plus 2/3. Y is equal to 2x plus, if I add these two fractions, it will be 8/6. So this is the equation of the tangent line to the curve at point P. And so far, I think this part most people are quite happy doing. Now part B is asking us that the tangent at another point Q on the curve is parallel to the tangent at point P. And it wants us to find the coordinates of point Q. Now, if you'd like to give this a go, pause the video now and see if you can find the solution. And then you can come and continue with this video. Okay, now, how would we do that? Just let's have a little sketch of the graph here. Because it's a cubic, I think it may look something like that. Now, we know that at some point P, there is a line, say like that is tangent to the curve. You must excuse my drawing here, but anyway, that's our line, which is tangent. So at another point Q somewhere else, we have the same line parallel to P, which would be at some other point Q. Let's assume Q is somewhere down here. But the crucial point to notice is that the gradient at this point is the same as gradient at that point. Now we found that the gradient at point P is equal to 2. So if the gradient is dy dx, dy dx at points P and Q must be equal to 2. And because this is a cubic, y is a cubic curve, if I differentiated dy dx, as we saw earlier, was a quadratic expression. So if we set that equal to 2, then we should get 2 points where dy dx is equal to 2. One of them is obviously the point P, because we have just been told that, and then the second part will give us Q. So what I'll need to do is to differentiate this again. So I have dy dx is equal to x squared. Then I have minus 2x. And I have minus 1. And I will set this equal to 2. And then we need to solve this quadratic equation. So this becomes x squared minus 2x minus 3 is equal to 0. This factorizes to x plus 1 to an x minus 3. X plus 1 we already would know, because we were x minus 1 was the coordinate of P, so that's where the tangent was equal to 2. So our second point, the coordinate of Q, x of Q would be equal to 3. So from here we have x of Q. If I substitute this into my equation for y of Q would be equal to 1/3 of 3 cubed minus 3 cubed, which is 9, minus 3, and then plus 1. And this will equal to 3 cubed is 27, divided by 3 is 9, minus 9 is 0, and minus 3 plus 1 becomes minus 2. So the coordinates of Q, right here, Q has got coordinates of 3 and minus 2. I hope this has been useful, but I'm going to demonstrate all of this to you graphically using Desmos. Now here we can see the curve y equals 1/3 of x cubed minus x squared minus x. I think there's a plus 1 here somewhere, which is not showing at the moment. Yeah, plus 1 there. So this is the equation of a curve, and at point -1, which is here, if I plot the graph, that is a tangent, and that is the equation that we found with the our a here would be 2/3, which is it's 8/3 it was, if you remember, which is about 2.6. If I can do that right. This is our our first tangent at point P, but if I now want to find the tangent at point Q, we know if we move the slider, these are all the lines which are parallel, and they have parallel. Obviously, they have the same gradient, so there will be one of them at this point, and the other one would be down here somewhere. And I have calculated the details of that line. If I click this button here, and that's our second line, which is, I think it comes out to 2x minus 8, because if we put the coordinates of point Q, but this is graphically representing what our question asked. That first we had the curve, we were given a point, some -1 up here, and we were asked to derive the equation of the tangent, which we did, which was 2x, in this case a, I've put a parameter, but it's really 8/6, which it's 2.6. So there you are. So that's the equation of the tangent at that point. And to find the coordinates of Q, what we did, we differentiated, let me see if I can go back. Yeah, we differentiated our curve. We set the gradient to 2, and we ended up with a quadratic which has two answers. One of them was the -1, which we had already been given, and we found the equation for the tangent line. So the next coordinate point would be the coordinate of the point Q, which is x equals 3. And from x equals 3, we substituted back in the original equation, and we find the y coordinate. So the x equals 3 and y equals -2 are the coordinates of point Q. I hope this has been useful. Please give this a like and click the subscribe button, and I'll see you in the next video.